We're going to use the definition of the derivative to differentiate f of x equals x squared minus 5x plus 12. Recall the definition of the derivative is f prime is equal to the limit as h approaches 0 of the difference quotient f of x plus h minus f of x divided by h. Now sometimes instead of h, delta x is used. So if you see a book, if your textbook uses delta x approaches 0, simply replace everywhere you see h here, replace it with delta x. But it's pretty much the same thing. So we're going to do this in 4 steps. Step number 1, we're going to compute f of x plus h. And the way to do that, go back to the function that we have, which is polynomial x squared minus 5x plus 12. First, replace every x that you see with a pair of parentheses. So we have, instead of x, we have parentheses squared minus 5 times parentheses. And then 12 doesn't have an x, so it stays 12. And now, in these parentheses, put x plus h. So this is what f of x plus h looks like. We can further simplify it by expanding. X plus h squared is x squared plus 2xh plus h squared. And then we have minus 5x minus 5h plus 12. That's the end of step 1. Step number 2, we're going to compute f of x plus h. That's what we did in step 1, but subtract from it f of x. So bring in f of x plus h, x squared plus 2xh plus h squared minus 5x minus 5h plus 12 minus, in parentheses, f of x, which is x squared minus 5x plus 12. Now what should happen here, everything that doesn't have an h in it should cancel. So we start with x squared minus x squared, that's in parentheses, they cancel. The next term without the h, minus 5x minus a minus 5x, they cancel. And finally 12 minus 12, they cancel. F of x cancels. Everything that doesn't have an h is gone. And we can say now, simplify f of x plus h minus f of x is 2xh plus h squared minus 5h. Let's factor out an h. So this is h times 2x plus h minus 5. That's the end of step number 2. End of step number 2 should always have an h. Sometimes it will not be possible, but in many cases we should always, at the end of step 2, factor out an h. Here's step 3. Take f of x plus h minus f of x. That's what we did in step 2, and just divide that by h. Well, what we did in step 2 makes it very easy because we bring in the numerator, that's h times 2x plus h minus 5, and divide that by h, and the h's cancel, and we're left with 2x plus h minus 5. That's the end of step 3. Step 4 is to finally compute the derivative. The derivative, f prime of x, is equal to the limit h goes to 0, f of x plus h minus f of x divided by h. We have that now. This is the limit as h goes to 0 of 2x plus h minus 5. Notice that h goes to 0, not x. So 2x and the 5 are completely untouched. The h that you see in the middle, that goes to 0. We end up with a final answer of 2x minus 5. So to summarize it, using the definition, when we have a function f of x equals to x squared minus 5x plus 12, its first derivative, f prime of x, is equal to 2x minus 5.